All right, welcome back everyone. So this is our second video for topic 1, tools of the trade. So we've already covered the first part of topic 1. So that was what is the process of science. So now we're going to get into how we measure things, and we're going to introduce ourselves to the metric system. So we're going to go over our learning objectives. Always a good idea to write these down, and then by the end of the video be able to address them. So the first learning objective is give meanings to the metric prefixes and be able to convert one unit into another unit. We should also be able to use the correct metric units to measure mass, length, volume, and temperature. So by the end of this video, you should be able to do both of these objectives on your own. All right, so let's talk about the metric system. So most of us are not familiar with it. So the metric system is something that the entire world uses except for us Americans. We are unusual. We use the American system or the English system. England doesn't even use the English system anymore. They use the metric system. But we have to be unusual, and so we use the old English system, or what we call the American system now, to measure things. So science, because science, we have to make sure that all scientists around the world use the same type of measuring scale. Scientists, they use the metric system. So since we're in a science class, we use the metric system as well. So we'll get a taste of using the metric system in this course. So when we're measuring things, we have 4 ways that we measure things. So we measure things by weighing things. So our base unit for weighing things is in grams. Okay, so we're not measuring things in pounds or ounces like we would in the American system. We would measure it in grams in the metric system. So the base unit is grams. And the abbreviation for that will be a G. If we want to measure the length of something, that would be in meters. So we don't use feet or inches, we would use meters. And the abbreviation for that would be M. If we want to find the volume of something, like a liquid, we would use liters, so not cups or gallons, it would be liters, and that unit abbreviation would be an L. And then finally, temperature. So temperature is Celsius or centigrade, so that would be, we would use the degree, that degree symbol with a C, okay? So you can see kind of, the different conversions, and you can kind of compare that to what you know with the American scale. So when you go to the gas station and you're filling up your car in gallons, well, if you go over and fill your car with gas over in Europe, it's being filled in liters instead. So you can see that, 3.79 liters is a gallon. Okay, so a little bit different. If you want to weigh yourself, how many pounds you are, in Europe, you're measured in kilograms. So it's kind of nice because you're obviously less kilograms than pounds. So hey, you step on a scale and you're like, a lot less kilograms than pounds. So 2.2 pounds to a kilogram. And then length, we have 1 mile to 1.61 kilometers. So this you might be more familiar with if you're a runner. So if you've run like a 5K or a 10K or even a marathon or something like that. But 10K, it's 10 kilometers. So you might be more familiar with that. And so things like that, you probably might not be familiar with those conversions. We won't be really converting much from the American system to the metric system, so this is just more for your own understanding. And then as far as temperature, room temperature in Celsius is usually around 22 degrees. So that's kind of maybe more familiar. you know, if you see something like that in your workbook. Also, body temperature. So you know, you're familiar with your body temperature is usually like 98 degrees. In Celsius, it's about 37 degrees. So that's a little bit different than you're used to. But boiling point and freezing point of water is a lot easier to remember, because in Fahrenheit, it's weird. It's like 32 degrees is the freezing point, and I forget, 212, is that right for the boiling point? I can't remember. But for the metric system, it's easy to remember. 0 degrees for freezing, 100 degrees for boiling. So that's really easy to remember, 0 and 100. Okay, so that can be a lot easier for the metric system. So let's talk about the metric prefixes. So when we talk about the metric system, it's actually an easier system to learn because it's a base 10 scale. So if you're familiar, you know, we're all familiar with the American Standard System, but the conversions are really weird and hard to learn. So for example, if you take a look at length, you have, you know, how many feet are in a, or how many inches are in a foot? You got 12. Like, who came up with 12? And then you got like 3 feet in a yard. Like, how did you come up with 3 feet in a yard? And then how many feet are in a mile again? It's like 5,280, I think, which is weird. Like, who came up with that? Like 5,280. What person just decided that's gonna be our standard conversion for something called a mile? I mean, that's just weird. So the metric system's a little bit different. It's very easy because you just do like a base 10 scale. So if you look over here, it's just by tens, okay? So we have our base 10. So the base unit would be our grams or our meters or our liters, okay? So if we want to go up 1,000 times, okay, so 1,000 times, you know, 1,000 meters, it would be a kilometer, okay? So 10 to the third power, kilometer, kilometer, okay? If we want to go smaller and go to the 100th scale, so the 10 to the minus 2, you know, 0.01, that would be centimeters or centigrams or centiliters, okay? So kind of easier to deal with instead of, you know, figuring out like 12 inches to a foot. Milli is thousandth, okay? So 10 to the minus 3, that's 0.001. So a little easier to deal with just by, you know, adding an extra 0 before the or after the decimal point. We're just changing the prefix. Okay, micro is adding 3 more zeros to the millionth, okay? Nano is the billionth. So as far as the purposes of this class, we just need to know these 5 prefixes. You don't really need to know these guys up here. So kilo, centi, milli, micro, and nano. So kilo would be 10 to the third, okay, or 3 spaces out to the left of the decimal point. Centi is 10 to the minus 2, or 2 spaces to the right of the decimal point. Milli is 10 to the minus 3, or 3 spaces to the right of the decimal point. Micro is 10 to the minus 6, or 6 spaces to the right of the decimal point. And nano is 10 to the minus 9, or 9 spaces to the right of the decimal point. And then as far as like abbreviations, when we're doing the abbreviations for this, we use basically the first letter, with the exception of micro, and then the first letter of our base unit. So if we're talking about meters, remember meters was M, liters was L, grams was G. So if we're talking about kilometers, it would be km. Centimeters, cm. Okay, millimeters, mm. If it's micro, we use this weird U. It's like a strange U. So it would be UM. Okay, and the nano would be NM. Okay, if we're doing kilograms, KG, CG, MG. Weird looking UG, okay, NG. If it's liters, KL, CL, ML, okay? So that's how we would write them in our measurements. Okay, so if you have those memorized, then it's easy to convert from one unit to another. So this is something similar to what you have in your workbook. It's not in the textbook, but I thought I'd put this in this presentation just so that you get used to it for the workbook part. So this is called a metric system staircase, and I like to have this handy. It's just useful for me to kind of visualize when I'm converting from one unit to another. So in this kind of center is the base unit. So that would be our meters, grams, or liters. And then you can see going up the staircase is the, bigger than 1. And then going down the staircase is less than 1. And then again, for the purposes of this class, you basically just need to know kilo, centi, milli, micro, and then nano is way down here. It's off the chart. Okay, so to do this, we're just going to take the base unit, and then if we have something that is basically, if we're going to move the decimal point to the left, okay, so if we're moving up the staircase, we're going to move the decimal point to the left. If we're moving down the staircase, we're going to move the decimal point to the right. So for example, let's say that I have 10 meters. That's what I'm starting with, and I want to convert it to kilometers or kilometers. So my decimal point currently is right here, and I need to move it how many spaces? Well, remember kilometers was 10 to the 3rd power, so I need to move it 3 spaces. 1, 2, 3. So I'm going to move that decimal point 3 spaces. 1, 2, 3. So I got to fill in the 0. Okay, so there's my 0. So now it's 0.01 kilometers. Okay. If I want to convert my 10 meters to millimeters, let's see, millimeters is 10 to the minus 3. So now I'm moving down the staircase. So I'm going to move that decimal point to the right. So I'm going to move it, here's my 10 again. So I'm going to move it to the right 3 spaces. 1, 2, 3. 0, 0, 0. So now I have 10,000 millimeters. Right? Okay, so you can kind of move the decimal point up or down, right or left, depending on which direction you're going. So here's a couple examples that are given to you in this example here. We have, for example, we have the centimeter to millimeter, so centi to milli. So remember, centi is 10 to the minus 2. Okay, and we're moving from centi to milli, so 10 to the minus 2 to 10 to the minus 3. So we're moving 1 step to the right or 1 step down. So we're just moving that decimal point 1 spot to the right. So that would be 20.7. We're going meters to centimeters. So here's our base unit to centi. So that's 2 steps down, or moving that decimal point 2 steps to the right. 1, 2. So it's 43.5. Millimeters to centimeters. So now we're going the opposite direction. We're going 1 step up or 1 step to the left. So we're moving that decimal point 1 step to the left. So 8.06. Okay. Okay, so you'll get lots of practice with the metric system, metric conversions, when we get into that section of the workbook. So let's make sure we're understanding the prefixes. So match the following prefixes with the correct metric equivalent. So micro, was micro 10 to the minus 9, 10 to the minus 6, 10 to the minus 3, or 10 to the third power? If you chose 10 to the minus 6, I would agree with you. How about milli? Which one was milli? 10 to the minus 9, 10 to the minus 3, or 10 to the third? If you said 10 to the minus 3, I would agree with you. How about kilo? 10 to the minus 9 or 10 to the third? It was the bigger than 1, right? So that was 10 to the third. And then nano is the teeny, teeny, tiny 10 to the minus 9. And then finally, what is the freezing temperature in degrees Celsius? Was it 0 degrees, 100 degrees, minus 4 degrees, or 32 degrees? If you chose A, I would agree with you. So that's the easy one. In the metric system, you just need to know, boiling point 100 degrees, freezing point 0 degrees. So simple. Whereas with the Fahrenheit, it's weird. You got like 32 is the freezing point, and I don't remember, the boiling point is like 212 or something. So yeah, so the freezing point in the metric system is 0 degrees Celsius. Very easy to remember. All right, so by now you should be able to give meanings of the metric prefixes. So that would be kilo, centi, milli, micro, and nano, and be able to convert one unit to another. And then also use the correct metric units to measure the mass, the length, the volume, and the temperature. So that would be grams, meters, liters, and Celsius, and then the various parts, so kilogram or whatever like that. Okay, so make sure you understand those, and then you can go ahead and move on to answering those questions in the textbook if you haven't done so already. And then you can go ahead and move on to the workbook part if you'd like. And then finally we have our next video, which will go into microscopy. So I'll see you there.